Objectives. Using the commutative, associative, and distributive property, simplifying algebraic expressions.
Simplifying algebraic expression using property of real numbers. Logical evolution. Algebraic expressions involve negative numbers and variables. On this basis, we have to develop new properties, commutative and associative, and then we will focus even more on distributive property, because all of this property will allow us to simplify algebraic expressions. This is what we are going to practice on the next slides. Commutative property for addition and multiplication. Changing the order when adding or multiplying does not affect the answer. Look into first example. -3 and +2 equals +2 and -3. Second expression with variables. X and +2 equals 2 and +x. This is commutative property for addition. For multiplication, -2 times 10 equals 10 times -2. Expression with variables. X times 10 equals 10 times x. This is commutative property of multiplication. These two properties we will use when we will simplify algebraic expressions. Associative property of addition and multiplication. Changing the grouping when adding or multiplying does not affect the answer. Example number 1. Parenthesis. -1 and +3 and +2 equals -1 and parenthesis +3 and +2. Or we can show the same property using variables. A and +3 within parentheses and +2 equals A and parentheses 3 and +2. Associative property of addition for multiplication. 2 times parentheses 3 times 4 equals parentheses 2 times 3 times 4. Expression with variables. 2 times 3x equals parentheses 2 times 3 times x. Associative property of multiplication. We will use this property when we have to simplify algebraic expressions.
I want us to review product rules before we will work out distributive property. Rule number 1. Positive times positive result is positive. And here example number 1. 3 times 4x using cross, or 3 times 4x using parentheses, or 3 times 4x using dot. And the result would be 3 times 4, 12x. Rule number 2. Positive times negative result is negative. 3 times -4x, or 3 times -4x using parentheses. Result would be positive times negative, negative, and then 3 times 4, 12, and we have to keep x. Rule number 3. Negative times positive result is negative. Example number 3. -3 times positive 4x, or you can show -3 and then 4x within parentheses, or -3 times 4x using dot. Result would be -12x. And last rule, negative times negative result would be positive. Example number 4. -3 times -4x, or we can use -3 and then -4x within parentheses, or both of them can be in parentheses, and the result would be positive 12x. Now we are ready to learn the distributive property. To introduce this property, we will evaluate 2 times parentheses 5 and 3 in two ways. If we want to use order operations, we would simplify 5 and 3 within parentheses first, and it will be 8, and then 2 times 8 is 16. And now another way will be distribute the multiplication. Look what we are going to do. We are going to multiply 2 times 5, it will be 10, and then 2 times 3, it will be 6, and 10 and 6 is 16. This method is coming practically from arithmetic, but it's very helpful in algebra. And distributive property says A times parentheses B and C will be equal A times B and A times C. I copy distributive property again, and now example number 1. We have positive 2 times parentheses 5x and positive 3, and we have a request simplify. As you remember, we have to simplify parentheses first. Let's look what we have within parentheses. Positive 5x and positive 3. They are not like terms. We can't combine them. This is why we have to use distributive property if we want to remove parentheses. So we will multiply 2 by 5x, or positive 2 times positive 5x, and it will be 10x, and then we will multiply 2 times 3, or positive 2 times positive 3, and it will be positive 6, and we're done. Similar example number 2. We have negative 2 times parentheses, and again we can't combine 5x and positive 3. They are not alike. In order to remove parentheses, we have to use distributive property. So we are going to multiply negative 2 times positive 5x, and the result will be negative 10x, and then negative 2 times positive 3, and the result will be negative 6. We're done. And example number 3. In this case, 5x and negative 3 within the parentheses. Again, we can't add them because they're not like. So we have to use distributive property. But in this case, we have to multiply by fraction, which is 4 over 7. So we will multiply positive 4 over 7 times positive 5x over 1. And we will have 20x over 7. And then positive 4 sevenths times negative 3 over 1. And we will have negative 12 over 7. We're done.
In arithmetic, we practice order of operations for multiplication and division, and then for addition and subtraction. And now we know that in arithmetic, we practice practically positive numbers. In algebra, we add negative numbers and variables. This is why we have to change order of operations. So first, we will use the distributive property to remove parentheses, and then we will just combine like terms.
Let's compare order of operations in arithmetic and in algebra. Example number 5. We have request simplify. Instead of multiplication and division from the left to the right, we will use idea, use the distributive property to remove parentheses. So we will multiply negative 7 times positive 3. It will be negative 21, and then negative 2 times x, negative 2x, negative 2 times positive 1, negative 2, and we will keep 3. After that, instead of addition and subtraction, we will use idea combining like terms. Order doesn't matter. So first identify like terms, negative 21, negative 2, and positive 3, constant terms. It will be negative 20 and negative 2x we have to keep. Now example number 6. What we have. In order to read this example, it could be a good idea to use magic number 1 if you want to use distributive property. Then we have to see better. Now we can use negative 1 times positive 3 will be negative 3, negative 1 times x, negative 1x, and negative 1 times positive 1, negative 1, and positive 3 we have to keep. After that, request combining like terms. Okay, let's identify like terms, constant terms. Negative 3 and negative 1 and positive 3 would be just negative 1, and we have to keep negative 1x. Example number 7. Using distributive property require those magic number 1s. And you can see, because you have to remove parentheses, you have to see what you're doing. Positive 1 times positive 3 is just 3. And here is positive 1 times x, it's just 1x. Positive times positive would be positive 1 and then 3. Now combine the like terms. 3, 1, and 3 will be 7, and 1x we have to keep. Idea about magic number 1s good not only when you have negative sign in front. It's a good idea even if you have positive sign. In order to remove parentheses, then you can see your example better and you can work out. Example 7b, simplify. In order to simplify, we have to remove parentheses, so we have to use distributive property. First, we have to distribute the multiplication by negative 3 and then by positive 7. But for each multiplication, we have to determine the sign first using the product rules. First group, negative 3 times positive x. Negative times positive would be negative 3x. Negative 3 times positive 5. Negative times positive would be negative 3 times 5, 15. Second group, positive 7 times negative 3. Positive times negative would be negative, and then 7 times 3, 21. Positive 7 times positive 1x would be positive 7x. After that, we have to identify like terms. Negative 3x. Do you see more term with x? Yes, positive 7x. Constant term, negative 15, and constant term is negative 21. Let's combine term with x's. Negative 3x and positive 7x would be positive 4x or just 4x, and then negative 15 and negative 21 would be negative 36. Example number 8 has fractions. So we have to distribute the multiplication by negative 2 over 3, and we have to distribute the multiplication by positive 7 over 2. For each multiplication, we have to determine the sign first using the product rules. Let's do it. Negative 2/3 times positive x over 3. Result would be negative 2x over 9. Then negative 2/3 times positive 5 over 2. Result would be negative 10 over 6. Second group, positive 7 over 2 times negative 3 over 1 will be negative 21 over 2. And then positive 7 over 2 times positive x over 2 would be positive 7x over 4. Next, we have to identify like terms. So the first term, negative 2x over 9, has variable x. Do we have more terms with variable x? Yes, the last one, positive 7x over 4. Now let's look for constant terms, just numbers, negative 10 over 6, and negative 21 over 2. And because we have fractions, so it's a good idea to regroup like terms to see better what to do. So the first group will have terms with x. It will be negative 2x over 9 and positive 7x over 4. And second group will be just a group of constant terms, negative 10 over 6 and negative 21 over 2. Each group has fractions, so we have to find the least common denominator for each group. For the first group, the least common denominator will be 36. For denominator 9 and 4, the least common denominator is 36. For the second group, the least common denominator is 6. For denominator 6 and 2. Now, we have to multiply each term in first group by appropriate one in order to have the least common denominator equal 36. So we will multiply by 4 over 4 first fraction. We will multiply by 9 over 9 second fraction. Now let's work out group with constant terms. So we have to multiply by 1 only second fraction, and this one would be just 3 over 3. Simplifying, and as a result we will have negative 8x over 36 and positive 63x over 36. We can combine and it will be 55x over 36. And next group, negative 10 over 6 and negative 63 over 6 would be negative 73 over 6.